working on, all right, we're working on Algebra 8-6, and this is solving quadratic functions by factoring. So here's where you have to be careful. If you did not finish 7-6, 7-7, maybe even 7-5, this, you're going to be a little bit lost when we're factoring down here. So we're going to have to probably back up and teach you making sure you know how to factor before you're solving this, because you need to factor. So we have here, remember our roots or our zero, like when the quadratic goes, when it crosses the x-axis, those are our zeros. The reason they're the zeros is because the y value is 0 in both of those. So we call this the zero product property. Simply states that if a times b equals 0, which means anything, if it's multiplication, then that means either a is 0 or b is 0. So the zero product property just means when you're multiplying, that's product, one of these are 0, your answer is going to be 0. So, for example, using the zero product property here, we have these two binomials. We have x plus 1 times x minus 5, and it equals 0. That means this can be 0 or this can be 0. So this total can be 0 or this can be 0. Well, we've got to think about, well, which one, like what does x have to be in order to make this 0? Well, if you think about it, well, it's going to be -1. So what you're really doing is you're saying x plus 1, that this total can equal 0, or x minus 5, that can equal 0. Well, then you can figure out, well, okay, so that's going to be -1. You're right, that's going to be -1. Or x can be equal +5. And that would make this 0. So if you're -1 here, that'd be 0 times whatever this is. Well, that would be same thing, -1. Yeah, x would be the same number. And then what would that, -6? So 0 times a -6 would be 0. So it doesn't matter which one is 0, but the two solutions, two answers, that's going to be -1 and that's going to be 5. So you can write it like that, or you can write it with set notation. Oops, set notation, -1, 5. Don't write parentheses because it looks like an ordered pair then. All right, so that's fairly simple. It's just opposite of what those are. But let's look when you have this. Well, you have 7n minus 2, so you got to think about 7 times something minus 2 is going to give you 0. Or 5n minus 4, 5 times some number minus 4 gives you 0. So the best way to do this, since this can be 0, or 5n minus 4 can be 0, this is how I do it. I just split it to two equations. Then you just solve your two-step equation. You're going to add 2, 7n equals 2, divide by 7, n equals 2/7. Now, guess and check, you'll probably take a long time to do that. So I go right into just solving. Add 4, 5n equals 4, n equals 4/5. So your two solutions are 2/7 and 4/5. Okay, now you can write in set notation if you want. So 2/7 and 4/5. Okay. So I would set it up equal to 0 and then just solve it. Okay, now we're going to apply this rule to our factoring. Okay, so here's what we're doing. So we have this example, and we have, y equals x squared plus 3x minus 10. Sometimes y is a number, okay? So sometimes the y is a number, and we have to bring that all over to the other side. So we always like to make sure that the equation's in standard form, which this is, and it's set to equal to 0. So I'm going to go ahead and replace the y for 0. And you can do it, I kind of like it on the other side. I'm going to flip this around. Not that it matters. Now you want to factor. Now the slip and slide method, you just factor trinomials. Now this is the a term is 1. So you can either do the x method, the -10 and 3 that you were working on in chapter 7, or unit 7. So remember, you're looking for multiple numbers that multiply to get -10, but add together to get 3. Okay, so that's going to be 5 and 2. Now, 5 and 2, one of them's negative, but 3 is positive, so that's going to be a negative 2. So you're really saying x, minus 2 times x plus 5 equals 0. Now you could switch that around. It doesn't matter. You can have x plus 5 and x minus 2. Okay, so then from here, that's kind of very similar to that. If it's just like this with the x is just 1, this is going to be x equals 2 or equals negative 5. So what we're doing is we're trying to find the zeros. This is where it would cross. These are the numbers that will cross the x-axis. Okay? All right, let's look at this next one. So we're going to solve by factoring. So if you want to do the x here, that's 3 and that's 4. So what numbers multiply to get 3, but then add together to get 4? Well, that's going to be 3 and 1. So you're going to have x plus 1, x plus 3 equals 0. And then, like I did up here before, you could think about this as x plus 1 equals 0 and x plus 3 equals 0. Well, that's going to be x is going to be negative 1 or x is going to be negative 3. Okay, so you can leave it like this or set notation. Sometimes your Delta Math, what I saw in the Delta Math this last assignment, they would accept either one. Oh, actually, they're doing the ordered pair on that one. So I don't know if they'll do that here or not. They might have you do set notation. We'll look at it. Okay, so again, factoring. X is, the A value is 1. So when the A value is 1, you can go right into thinking about what multiplies to get a negative 20, but then add together to get negative 1. Well, 5 and 4 multiply to get 20, they're 1 apart. So now that's a negative 1, so that needs to be a negative 5. X minus 5, x plus 4 equals 0. So then you're just saying x minus 5 equals 0 or x plus 4 equals 0. What we're doing here is we're finding where the parabola crosses the x-axis. And these are at the points where they cross the x-axis. Okay, so you can do, sometimes they even do them in order, like negative 4 or 5. It doesn't really matter. Okay. So, all right. So that's factoring and using the zero product property. This is why it's really important on the end of Unit 6 or Unit 7 that you factored. Okay. Now we're doing some more factoring. Okay. So what I would do here, looking at your problem, you have it equal to 0, but notice you have an x squared minus 8x. I would take out you factor out an x, and you get x minus 8 equals 0. Now, your goal is to find what x can equal to make that 0. Well, there's an x on the outside. So what you can say is x equals 0 or x minus 8 equals 0, because that can be 0 or that can be 0. So your two solutions, x equals 0 or, so x is 0 is one solution, or x equals 8. If you add 8, that would make that 0. So you have 0, 8 as your solutions. Okay, again, not an ordered pair. That's not an ordered pair. The ordered pair is actually 0, 0 and 8, 0. Those are the two numbers. That's the 2 points that the parabola would cross the x-axis. Okay, notice here we have x squared plus 4x equals 21. Well, in order to factor this, we need to get the 21 over to the other side to make it a standard form. So we need to subtract 21 to move it to the other side. That's very, very important. If you cross the equal sign, change the sign. Now you just go right into factoring. Okay, so you can go into factoring. So I'm going to just do some key ones, and if we have time, we'll go back. But look at this one. So I'm going to go ahead and just set these up, and then you can go back and factor and do what we're doing. So x squared plus 8x, ooh, we have 11x squared here. So we are going to do, it almost make more sense if you brought, maybe if we subtract x squared, and 8x. Let's see if that works. I'm going to bring everything to this side. So I get a 10x squared minus 8x equals 0. So I'm going to bring these two over. I kind of like just the 10x to be positive if possible. So I'm going to subtract. I'm just checking my work. Okay, now from here, I would factor out the GCF. Look at 10 and 8. 2 can go into it. And look at x. So I'd factor out a 2x. And you get 5x minus 4. Okay. Now from here, then you can do 2x equals 0 or 5x minus 4 equals 0. Then you can finish. Okay, you have to finish that. Looking at this one, x squared minus 10x plus 49 equals 4x plus 1. Well, you want one side to be completely 0. So you want to subtract 4x and subtract 1. You make sure when you do that, when you bring them over, line them up to the like terms. Only combine like terms. You have x squared minus 14x plus 48. So what you're doing is you're bringing everything over you want it to equal 0. And just make sure and double check your work. I always do that, making sure, because I don't want to do all this work down here and find out I made one silly mistake up there. Okay. Then from here, slip and slide, don't worry about that. We're just doing the X method. Okay, so now, if you have a GCF, look at your GCF and see if you can. 3, 9, and 12, you can. So I'd take out the 3, x squared plus 3x minus 4 equals 0. I think that's probably exactly one that we didn't. We did similar. Now, here's where it's a little different. So notice there's a 3 here. Well, that's not going to make a difference in our final answer because we're looking for what x has to be in order to equal 0. So factor this is like normal. Okay, so we're going to factor x squared. That's going to be a negative 4 and a 3. So you're looking for what numbers multiply to get a negative 4, but add together to get 3. Well, that's going to be not 2 and 2, 4 and 1. So we're going to have 4 and 1. That's a negative, though, and that's a positive, so that's going to be a negative 1. So we have this, 3x minus 1, x plus 4 equals 0. Okay, now, this 3, it won't matter because one of these have to be 0. So I'm not going to even really use the 3 now. So I'm going to have x minus 1 equals 0 or x plus 4 equals 0. So x is going to equal positive 1 or x is going to equal negative 4. That 3 won't matter because one of these have to be 0. So your only two answers are negative 4 and 1. That's where it's crossing the x-axis. All right, so that's what you would do. So go through and factor those. And when you submit yours, if you have a question, just let me know. But when you submit it, I will be checking and making sure that these are completed. Okay, I'll return them to you if you're not. So make sure that these are completed. And that's what you're doing. You are factoring and finding the zeros or the roots or the solutions to those equations.